In the past, when we've been studying trigonometry, we've thought of trigonometry as, say, the study of triangles. So what we could have in this example is we've got a nice right-angled triangle here, and we'd say that this is perhaps angle theta. We've got a side length here of 10, or a hypotenuse of 10, and an opposite side of x. And what we'd usually do is something like find x. And for this would be our definition of trigonometry. So finding unknown sides and unknown angles. But we're going to move away from this simple concept of trigonometry. So we're going to move away from thinking of trigonometry as triangles, and then think of trigonometry as the study of angles. The study of angles. So what does that mean? Well, consider if I have, let's say I've got a Cartesian plane. So this is my beautiful y-axis, and this is positive y direction, and this is the negative y direction. And then over here I've got my x-axis, completing the Cartesian plane, and this is the positive x direction, and this is the negative x direction. Now what I'm going to do is I'm going to draw something on this Cartesian plane. What I'm going to draw is a circle, and I'm going to say the circle has a radius. I'll draw it there. It's got a radius of 1 unit. And what that means is that every point along this circle is a distance. So if that's the origin 0, 0, every point along this circle is a distance of 1 unit away from the origin here. Now consider if I've got a point along my unit circle. Let's say there's a point up there. And what I'm going to do is I'm going to draw, it's not quite right. Let's go again. I'm going to draw a line to my point, and then I'm going to draw it such that the line drops down as such and then moves across. So we can see that this point on the circle here has a horizontal component, or an x value, and the y value, so length. And what we find is that this internal angle here is 90 degrees, and we'll say that this angle here, this is theta. Right, and based on this triangle we've got here, we can say the point here is located at x, y. Now, the first thing we want to know is, well, how can we describe this point along this unit circle here? And we can do it using trigonometry. So this y component here, notice that it represents the opposite side relative to our theta, and this one represents our adjacent side relative to our theta. So if we use our sine and cosine ratios, so sine equals theta equals the opposite over the hypotenuse, and our cosine equals our adjacent over the hypotenuse. What we can do is we can have values to explain the x and the y coordinates here. So subbing everything in, notice this is a unit circle, so this hypotenuse is 1 unit in length. So therefore we're going to get sine of theta equals the opposite over the unit of 1. And remember that this opposite represents the y coordinate. So we're going to get sine theta equals y, or y equals sine sine theta. Now similarly for the adjacent, we're going to go in a similar direction in that cosine of theta will equal adjacent over 1, the adjacent over a unit of 1, and then the adjacent subbed in as the x value. It's going to be x equals cosine of theta. So now what we've got is, we've got a convention. So rather than explaining it in terms of x and y, what we can do is we can explain this position of our point along this unit circle in terms of cosine of theta and sine of theta. So for any point along this unit circle, so here, 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 or here, any point along this unit circle can be explained in terms of cosine theta and sine of theta as such. So over here as well. Now this has interesting implications on the values that we expect to come out of cosine and the sine functions. So notice that we're working in the full range of this Cartesian plane, and what we expect is that when we're on the right hand side of the y-axis, we're expecting positive values for x, but for the left hand side of the y-axis, we're expecting negative values for x. So notice that if we had, say, a convention where we said the angle itself, if we start at the x-axis, we will define that as 0 degrees. For positive angles, we're going to go in a anti-clockwise direction. So positive angles, anti-clockwise direction. For going in an anti-clockwise direction, we're going to get positive angles going anti-clockwise. So at the y-axis, we're going to hit 90 degrees. When we exceed 90 and we're between 180 degrees, what we find is that we're going to expect the output of cosine, which represents our x-axis values, they're going to be negative. So what we're going to see is negative cosine values. But notice the sine values, they're still going to be, in this case, the sine values are still going to be in the positive y area. So we're going to see positive sine values. Now going further down, if we're in this region between 180 and let's say this is 270 degrees here, notice that we're going to be in the negative x region and the negative y region. So we're going to expect to see negative values of cosine and negative values of sine. And then in this fourth quadrant here, so between 270 and say that's 360 degrees, we're going to expect to see positive cosine values because we're in the positive x region and negative sine values. So what we've got here is a very cluttered unit circle diagram, but what we find is that this diagram here, we call it the unit circle, and what it tells us is it tells us the behavior of sine and the cosine function as they revolve or as they sweep around a range of 0 degrees and 360 degrees.